In Chapter 8, the first section, we're going to start talking about similarity. And if you remember, similarity is represented by this wiggle. Similarity means it's the same shape, but it's a different size. That size is going to change. So in our example here, what I want you to notice a couple of things. I have triangle ABC, I can see here, and it's similar to DEF. It means that these are the same shapes, so you can see they're the same triangles, but it's a different size. You can see AB is slightly smaller, and DEF has grown. It's a little bit bigger. Some things that are really important are all these matching colors. So while you're taking your notes, make sure that you do that. And what's important to see is, for instance, here, notice I put AB and DE in these pink colors, and I found it from here. AB are the first two letters, and they match with DE, the first two letters in this triangle. Those are really important to see and understand. So for instance, the second and third, BC, should match with the second and third EF over here. And I can see that they do. BC matches with EF. So the position of the triangles, this matters big time. So that's why I have this little dot A. Angle A, I can see right here, should match and be the same as angle D right here. So again, my sizes are going to be proportional. They're going to have a scale factor, but my angles, notice, are going to be equivalent. They're going to be the same. So one of the things that we need to do is figure out that ratio or that scale factor. So let's take a look at this example here. We can see these two triangles, and the similarity statement is here. It says triangle RST is the same as, similar to X, Y, Z. So I can see, for instance, we did RT, so side RT, the first and the last, should be, not congruent, I can't talk today, should be proportional to XZ. And I can see I've marked those two pieces. So I can set up my fraction there. I said that 25 and 15. So together these form a ratio, and I'm trying to figure out what that ratio is, or that scale factor. So then I can walk through and do the same thing. This time I did TS. So notice TS or ST are these last two. So they should match with YZ or ZY, which is 18. So you can see where I got my second fraction. And notice when I simplify both of these, they are the same. They're 5/3. You can take a look and see the last set as well. 20 to 12 also simplifies to 5/3. So this 5/3 is called the scale factor. And again, I know that they are similar because they have a common scale factor. In our next example, you can see these two shapes. Again, they are the same shapes. This time, though, they have four sides, so they are quadrilaterals. So they don't just have to be triangles, they could be any shape. These are the same shape, but different size. They are similar. So again, notice how I've kind of matched some of these up. I had AD in pink, this first and last, matches with QT in pink, the first and last. So these guys match up together. And of course, I wanted to know what my X matched up with because X is what I'm trying to solve for. So the X was BC. So I found BC were the two middle pieces. So it's going to match with the two middle pieces on the other shape. So RS and BC, these two would go together. So when I wrote that, and this gets a little bit crazy there, I'll write it over here for you. So I had X pairing with 4. So I went X to 4. That's where my arrow is here. I just have to be consistent and go the same direction. And then I have 10 and 5. So a couple different things. You could just cross multiply 4 times 10 divided by 5, and you're going to get 8. Another thing you could do is see and notice that this says 10 divided by 5, which is the same as 2. And you could think, what divided by 4 is also 2? And again, you know that it is